Welcome to Troubleshooting 101. My name is Patrick Slater, representative for Minka Aire in Northern California. Today we're looking at troubleshooting tips for faulty ceiling fans. The purpose of this presentation is to provide an overview of how ceiling fans work so that you can assist customers in troubleshooting their fan. I will first start by saying that Minka Aire has excellent resources for supporting technical support. Utilize this resource whenever possible. The technicians are able to run diagnostic tests over the phone to help quickly identify the root cause of the issue. Additionally, they can make recommendations for replacement parts to get your fan back up and running. Let's jump into it. Troubleshooting 101 will start with an introduction to fan motors, AC versus DC. Next, we'll discuss fan controls and the difference between hardwired controls and RF-based controls. Once we have a firm grasp of how fans operate, we will look further into parts involved, capacitors, and receivers. Finally, we will provide some practical pointers for diagnosing issues like programming and noise. AC versus DC motors. Minka Aire offers both AC and DC motor fans. Each have their own benefits. It's important to understand the basics of these motors to understand how to control them. AC motors use AC power, alternating current, and do not require a transformer or receiver. Residential homes are wired with 120-volt AC power, less energy efficient and typically larger in size. DC motors, on the other hand, are more energy efficient, typically smaller in size, and they use direct current power, DC power. These devices require a transformer in the fan to convert the AC current in the home to the DC current usable by the motor. How do we control fans? There are two main mechanisms for controlling fans. We can control them with hardwire controls or RF or radio frequency-based controls. Hardwire controls operate like a light switch, but by interrupting the electrical current or limiting electrical flow to the fan to slow the motor or dim the light. RF-based controls emit a radio frequency or RF signal through the air to the ceiling fan. Hardwire controls. Hardwire controls can be used to control the motor speed and light independently. These work by limiting the electrical current in the motor or the light, which causes the fan to slow down or dim. These are called hardwire controls because they control the fan via the wiring to the fan. RF-based controls control the fan by sending radio frequency signals to the receiver in the fan. In the example on the slide, we can see that the 120-volt power coming into the switch. The wall control increases or decreases the current supplied to the fan through the wiring of the fan. On speed 1, there is less electrical current flowing to the fan, and so the motor runs at a lower speed. Increase the speed to level 4, and you allow greater electrical current, so the motor speeds up. AC motor fans can be wired directly to the 120-volt AC boxes in your home, thus eliminating the need for receivers. Most pull chain fans are set up this way. Depending on the fan setup, AC motor fans will have 3 or 4 wires. 4-wire fans will have a black wire for the motor, a blue wire for the light, a neutral, and a ground wire. This allows you to use a hardwired control to control the motor, speed, and light independently as described above. How do I know if my fan uses a hardwired control? The best place to check is by accessing the specification sheet on minkagroup.net. The controls listed here are hardwire controls that control the fan by limiting electrical flow through the wiring. Hardwire controls are best for large projects like apartment buildings and mixed-use areas, as there is no risk of RF interference between the units. More on this to come. Additionally, many specifiers prefer hardwire controls on large projects because it eliminates the need for an electrical component called a receiver, which can increase the per unit cost of the fan and have a greater risk of failure. Can I use a remote if my fan comes with the hardwire control? Absolutely. Give that fan a brain by adding the compatible receiver and remote combo. In the case of the roto fan, some customers prefer to control the fan with a remote. Simply add the compatible receiver to the wiring circuit, program, and you're set. Radio frequency-based controls. Okay, so what are RF or radio frequency-based controls? Here's a simple flowchart. Let's say you're controlling your light wave fan, which uses an RCS 213 RF control. You press speed 1 on the remote, and a radio frequency signal is emitted from the remote through the air. The receiver in the fan picks up that signal, interprets it, and then tells the fan to turn on to speed 1. This is a very simple explanation, and we won't go into the specifics of radio frequency. However, it is important to note that RF devices are both reliable and abundant. The technology has been around since the early 1900s and is used in garage door openers, TV remotes, even baby monitors. So what is a receiver? A fan receiver takes the command of the RF-based remote or wall control, then directs an electrical current to the motor or light to perform that command. A fan receiver is an electrical component and more susceptible to issues caused by voltage fluctuations, power surges, etc. Most fan issues are receiver related, not motor or control related. Common fan issues related to receivers include the fan turning on and off by itself, fan not responding to the remote, noise, fan speeding up and down randomly. Where to find a receiver? The location of the receiver will vary by model. Most receivers will be located in the canopy of the fan, where the fan wiring connects to the junction box. However, some DC motor fans will have the receiver located on top of the motor housing. Either location is easily accessible, so replacement is straightforward. Utilize the tech support team at Minka to find the receiver location or refer to the instruction manual for wiring diagrams. Replacing a receiver is easy, however, it is recommended to use a licensed electrician or qualified handyman. Replacement involves disconnecting and then reconnecting the light-colored wires on the fan and receiver. Some DC motors receivers even have quick connects or Molex connectors, so it's even easier. Capacitors explained. A fan capacitor is similar to a receiver in that it is an electrical component of the fan. The capacitor stores startup power to get the fan moving at the onset and is also involved in speed changes. Issues with the fan starting, slowing down, or speeding up, or not changing speeds could be a result of a faulty capacitor. Capacitors are also easy to replace. Most are found in the fan switch cup, as noted on the illustration, or on top of the motor housing. The process of changing a capacitor is similar to that of a receiver. Simply match the light-colored wires together or use the provided quick connect. Programming RF-based fans. All radio frequency-based controls and fans must be programmed or synced prior to operation. This process creates a unique connection between the control and the fan. Establishing a unique connection using dip switches ensures that your remote only controls your fan, and not your neighbor's or your downstairs fan. Luckily, programming your Minka Aire fan is easy. First step is to turn off the power, then set a unique dip switch pattern on the control. Hang and wire the fan per the instructions, then turn on the power to the fan. The fan will go into program mode for 60 seconds. During this period, hold the stop button on the remote for 6 seconds. The fan is programmed when the light blinks twice or the motor shudders. More on dip switches. A few more points to remember about dip switches and programming RF-based fans. Dip switches should be set prior to programming the fan. There are only dip switches on the control, not the receiver. As mentioned previously, it is important to consider the number of fans in the same area on large projects. Minka Aire offers a variety of controls with different numbers of unique frequencies. 32-bit controls have only 32 unique channels and should not be used in situations where there are more than 32 fans in a range of 50 to 60 feet. 1024-bit controls have 1024 different frequencies to choose from and are best for larger volume projects like apartment buildings. In these situations, it's best to create a frequency matrix for each apartment unit so that each apartment has its own unique frequency. Next, let's look at some common issues related to ceiling fans. First, we'll discuss noise. Noise issues are generally caused by either the motor or the receiver. This flowchart helps to determine the likely cause of noise. However, it is important to note that you should always call technical support for an official diagnostic. Additionally, it's critical to check an installation instructions when you have noise issues. While noise can be caused by a receiver or motor defect, it can also be caused by simple installation issues like a loose piece of glass, over-tightened screws, or a wobbly canopy cover. If we look at our flowchart, the first step in troubleshooting noise is to determine if the noise persists when the fan is powered off. To do this, run the fan until the noise begins. Hit the stop button. If the noise persists, it's likely a motor issue. If it stops, it is likely a receiver or capacitor issue. There are additional steps you can take to nail down the root cause, as you can see. Here is a great time to pick up the phone and call technical support. They can continue diagnostics as well as offer insight into what needs to be replaced or fixed. Other common issues. Here are some other common issues you may see in the field. Fans will not program at all. This is likely receiver related. Check to ensure that the remote control is emitting a signal. If the green or red light appears at the top of the control when you press a command, the control is working. Next, ensure you are within range of about 50 feet max, and there are no major obstructions in between the control and the fan. Adjust the antenna on the receiver to ensure it's not crimped. Ensure you have power to the fan. Try using different dip switch patterns when programming the fan. If these tips do not work, it may be a faulty receiver. Other issues related to receivers and capacitors include the fan starting and stopping without command and speeding up or slowing down without a command. Common misconceptions. Here are some common misconceptions about ceiling fans you may run into. Number 1, my remote is not working. Remote and wall controls are simple electronic devices that emit a radio frequency signal to the fan. First, check and/or change the battery. If the LED indicator light is working, the issue is likely the receiver, not the control. The control only sends a signal to the fan, so if the light is activated when pressing buttons, it is sending a signal. The receiver is likely the weak link. Replacing the remote control but not the receiver will likely not solve the issue. All noise issues are related to the motor. Noise issues can be both mechanical, motor, or electrical, receiver and capacitor related. Refer to the troubleshooting steps to determine the root cause. Receivers and capacitors are hard to replace. Most receivers and capacitors are easily accessible and replaceable. A qualified electrician, skilled handyman, or DIYer can likely replace these quickly. Additional FAQs. How do I reverse my fan? All DC motor fans are reversible via the button on the remote or wall control. Some AC motor fans are considered full function and can be reversed using the remote or wall control. If the fan is not full function, the reverse switch will be located on the motor housing. Full function controls include RCS 212, RC 400, 500, 600, and 1000. Fans using the RCS 223 or RCS 213 control will have a manual reverse. Can I use my wall control and remote control together to control my fan? Yes. The best way to do this is to program the fan with the remote control first. Then install the wall control using the same dip switch pattern as used on the remote. The fan is already programmed to that channel and should respond to both controls. You don't have to go through programming twice. Do I have to use the receiver and remote that comes with the fan? Yes. Each Minka Aire fan has a unique receiver. Refer to the receiver list provided by Envision to find the correct receiver. Can you use one Minka wall control to operate 2 fans? While it's not advised, you can use one control to operate multiple fans. Each fan will need to be programmed separately. Please contact tech for guidance. The fan should be within range of about 40 to 50 feet. Please note that controlling multiple fans with one remote can sometimes lead to fans becoming out of sync. That concludes our fan troubleshooting guide. If there's something we didn't cover or you'd like to discuss, please reach out to us. We're here to help. Have a great day.